Guys, so welcome to Blue Tech Empire Python tutorials. In this video, we are going to be looking at the standard data types. In the next couple of videos, we are going to be looking at the standard data types, but in this video particularly, we are going to be looking at the numbers, the type numbers, data type numbers. So let's get directly into the video. Now, when you store data in Python, for example, the examples we have been seeing in the past, you can store numbers. For example, let's get into Python. You can store numbers like, say, score equals to 30. You can store an email. For example, email equals to blue tech empire at gmail.com. And you can also store even floats like maybe distance equals to 50.5. And so you can store different data types, complex, lists, and all the rest. Now, the data stored in memory can be of many types. For example, a person age, like we have score and age of a person, we like to store that as a numeric value. An address or email is stored as a couple of alphanumeric characters. Here we have BLUT and whatever. It's a couple of alphanumeric characters. And Python has various standard data types that are used to define the operations possible on them and storage methods for each of them. So Python has 6 main data types, which include numbers, strings, lists, tuples, dictionary, and sets. These data types make Python very, very powerful as a programming language compared to other programming language. You can do a lot. It makes Python very convenient for manipulating data, and it makes life very easy for a programmer in case you need to handle a lot of data or process text data. Python is very good in doing that. In this video particularly, we are going to be looking at numbers. So I'm going to be reading from the right, from the Blue Tech Empire channel on Telegram. It says number data type stores numeric data. For example, we have score here, 30, and we also have distance here, 50.5. Here, number, we can also have coordinates equals to 3 plus 5, 4j. Here is also a number. We have 3 types of numbers like we are going to be seeing later. The first, we have integers, we have floats. That's a number with a decimal point is known as a float. And lastly, we have a number with real and imaginary parts known as a complex number. 3 is the real part, while 4j is the imaginary part, and it can be in the form of a float. For example, you can write 3.0, and write, say, C1 equals to 3.0 plus 4j or 4.2j. All right. So there is an example. If we print C1, it's going to give us that. If we write type C1, it's going to show us it's a complex. So let's keep reading. So number data types store numeric data. Number objects are created when you assign a value to them. Like I explained in the video on variables, if you haven't watched it, I would advise you to watch it. On variables, we learned how Python creates objects. We talked about, just for as a hint, we talked about the fact that Python actually, when you assign a value to a variable, Python creates an object in memory. It first determines the type of that variable. For example, in this case, it's an integer because it's a number without a decimal point. In this case, Python detects it's a float. Python creates an object, saves that value in that object, and now points the variable name to that object. We talked a lot about this in the video on variables, so I'll advise you to watch it if you haven't watched it. All right, so let's continue. You can also delete a reference to a number object by using the del statement. When you delete a variable using the del, an error will be generated if you try to access that variable again. For example, you say a equals to 30, and B equals to 40. We can say C equals to A plus B, and we print out C. Let's see what C is now. Like we explained in that the variables on video, A is 30, so it's C equals to 30 plus 40, and now that's 70. Now, if we delete A like this, sorry, it's not A. Python is case sensitive. So if we delete A like this, and say we try to print out A again, it says A is not defined. Why? When we created A, Python assigned the tag or variable name to the object in memory A. Now, if you delete A, what Python does, it deletes this tag. The object might still remain in memory because, for example, let's say you have num1 equals to 30 and num2 equals to 30. We can check the memory locations where num1 and num2 point to by using id num1. We see the memory location of num1 in memory. Here is the address, and we can see id num2. We talked about this in the video on variables, so if you haven't watched it, you can watch it so you can follow up with us. So, but you can still move ahead. Here is just a sample of some things you might need to know. So we see both id num1 and num2 point to the same object. You can see the addresses are equal. What happens? Python just creates an object, places the value 30 in that object, and then points num1 to it. When you attempt to create another value num2 equals to 30, Python already has 30 as an object, so it just points num2 to that same memory location. So if you say there num1, Python isn't going to delete this object because probably another variable also points to it, and in this case, yes, num2 points to the object. What Python will normally do if you delete an object, if you delete a variable name, because in this case num1 is the variable name, you should know you aren't deleting the object, you are actually deleting the variable name. So in this case, Python is just going to detach num1 from this object, deletes it, so num1 doesn't exist anymore. But if you type id num2, you see the memory location still exists, and num2 still exists 30. So it's, but num1 does not exist because it's been deleted. Now you can delete multiple variables. For example, you can say A equals to 30, you can say B equals to 40.5, and we can print AB as a AB, which is 30 and 40.5. And later on, we can say, you can delete multiple variables by separating them with a comma. For example, we want to delete A and B, and maybe let's delete another number and say let's delete C. Remember, we declared the variable C here, so let's delete A, B, and C. So now if you try to print A, it gives us an error. Sorry, not this. A, yeah, it gives us an error. If we try to print B, it gives us an error, and if we try to print C, it gives us an error. Why? Because the reference A, or the variable name A, B, and C have been deleted from Python, or from our environment. Now, if we type dir command, we talked about this in the last video, we see we don't have A, B, and C. Again, we have only email. We created distance, and we created coordinate. If you can remember, at the top, we had distance, we had score, email, distance, coordinates. So I think they're still there. Yeah, you have coordinates, distance, email, num2, and score. So the other, if we delete num2, for example, there. In fact, let's print out num2 to see what it has. Num2. All right, it will delete num2, and let's say we delete distance. You see, and we do 0 again. You see, those variables no longer exist in the scope of the program. They have been deleted. Now we only have coordinate, email, score, and C1 left. So that's how the delete works. So When you delete a variable, what happens is that you delete the reference. Like I said, you don't delete the object, you delete the variable name or the reference to that object. You delete the reference that links the variable to the object in memory. Hence, the reference count of that object, like we learned in the video on variable, the reference count each time you create a variable or an object, for example, a equals to 30, creates an object with the value 30 in memory. If you say b equals to 30, B points to that object, but the reference count of that object is changed from 1 to 2 because now two variables point to that object. So like I said, if you delete, once you delete, if for example, if we delete B, the reference count of the object containing 30 now is only 1 because A points to it. If we delete A, now the reference count is 0, but the object still stays in memory for a while because later on in our code, we might create a variable, say score equals to 30. So Python wouldn't create 30. Instead, it will use this whole object and just point score to that object. So Python takes some time before deleting variables, and after a while, if the variable is in memory without any reference count, it will be garbage collected, like we learned in the garbage collection video. So you can also watch that if you would like to do. All right, so now let's look at what we have. The script below demonstrates the effect of the del keyword. We have already seen examples. So we have var1, 30.5, a float, var2 is an int, var3 is 120, an int, var4 is 756, an int. We printed out var1, we had 30.5. We printed out var4, we had 756. We deleted var1, deleted var2. You see, you can delete two variables, like I said, by separating them with a comma. Now, if you print var1, it tells you can't find that variable. var1 is not defined because it's been deleted. If you print var2, it tells you can't find that because we deleted var2 here. If you print var1, of course, it can't be found, but var4 still exists because we haven't deleted it yet. So that's just a basic example for you to see. Now, as you can see from the script above, after deleting the identifiers var1, var2, and var3, we can no longer use them. Now, Python supports three different numeric types, both positive and negative for each case. So, like we said, now if we exit this, and we use CLS and get back into Python so we can see properly. Now we have integers. We have been dealing with integers before. For example, a equals to 20, that's an integer. A equals to 1 million or 1 million, that's an integer. A equals to 6, 4, 5, 6, or whatever you write. Integers can really be long, and you can even have a equals to long. Python has no limit for this stuff, whatever. And you can even print a. You can print a, and you can even say type a, and you see, type a, and it's still an integer. So Python integers can really be long. If we want to find the length of that integer, we can convert it to a string and try to calculate the length. So we see it's 61. Here at 61, you can't, I don't think this actually exists. I don't think this number actually exists. So integers can really be long in Python. Unlike other programming languages, integers can be that long, but in Python, you can have really long integers. I think there's actually no limit to how long an integer can be. So examples of integers include 300, we have 90, 30, 20. You can even have a negative, for example, you can say score, or let's say distance, or distance equals to negative 30 or 40, or let's say angle equals to negative 35. So still an integer. Now, one other interesting stuff about integers is you can actually use different, let's say, different bases when declaring integers. For example, we know about hexadecimal numbers. Let's pop up a calculator here. We are programmer, you can go to scientific, we are programmer. Now, Let's see a few things from this. All right, let's see a few stuffs now. Let's see when we are decimal now. So let's see 200 in decimal. Let's see what it is. It's 13,200 in decimal. Let's see 200 in decimal. It's C8 in hex and 310 octs, and here is the value in binary notation. So let's try some stuff with that. Now we can say, normally if you want to define this as an integer, what you do is you can just simply say a equals to 200. Oh yeah, type a, you see a is an int, print a, print a. Oh, it's good to go. Now what of if you actually want to store that value as an hex or as a hexadecimal or decimal or octal? You can simply say, let's use b in this case. We can say b equals to save in hexadecimal, you use o, that's number o, followed by letter x, ox, and you simply type, in this case we see hexadecimal is c8, so if we type oxc8 and print b, you see it still prints 200. So normally, no matter the base you use to save an integer, internally it's saved as a decimal, is saved in decimal form. So you saw we said b equals to ox, which this ox is for hexadecimal, and we use the hexadecimal equivalent of 200, which is c8, and we say b equals to oxc8, and when we printed b, it showed us 200. And if we still say type b, we see it's an integer. Now let's try do it in hex, in oct, that's base 8. Hexadecimal is base 16. Now let's try octal notation. For octal notation, we use o like 0 and then small letter o. We use o, here we see 310. 310. That's, let's say this should be, we have used c. Now let's print c. You see it's still 200, so you can save a number in hexadecimal form. It has a lot of uses. Maybe in the future we are going to look at examples on why you want to do that. And let's see type c. You see it's still an integer. And lastly, you can save in the form of a binary notation. You know this decimal, for example, if you say a equals to 200, that's decimal notation. So let's look at binary notation. Now, binary notation, you have to use 0b to indicate binary. And in this case, it's 1100. For those who are not used to binary mathematics, you don't need to worry. In the case is 11001000. Let's say d equals to this. Let's print d. It's still 200, and let's say type d. Oh, it's an integer. So we learned from that. We see d is also an integer. So you can use any of these forms or notation to save an integer. You can use hex, like we saw here. You can use hexadecimal notation. You can use binary notation. You can use octal notation, or you can use the normal decimal notation like e equals to 200. This is the normal decimal notation. And don't forget, you can also convert from one notation to the other. For example, we know 200. If we say a equals to 200, to find, let's say we want to find the binary form of a, we can say, you can form the binary form. You just need to say bin a gives us 0b111, like just what we did before. If you want to convert an integer to its hexadecimal form, you just simply say hex a, and you see it gives us c8. You can even say hex 15, and it should give you ff oxf, or you can say hex 255, and it should give you ff oxff. For those who know about or hexadecimal stuff, you understand exactly what I'm doing. And to convert to octal notation, you use oct, for example, 200, and you see it gives us 310. So we can also have another oct, 400, and it gives us 620. So you can do all that. I just want to show you how you can use different notations to define an integer. Next up, we have the variable, the numeric type float. Now, what is a float? We can exit this, and we can clear the screen, and we can get back to Python. Now, whenever you declare a variable, for example, a equals to, or let's say 46.6, or b equals to 60.78944, whatever, Python uses a float to save these variables. It's no longer an int. For example, if you say int, we find the type by using type a. Find, sorry, I always use this capital letter. Find it's a float. We find type b, you see it's a float. Unlike when we declare an integer, for example, if you declare a number without a decimal point, let's say c, or let's say num1 equals to 50 or 5000, you see it doesn't have a decimal point, so Python saves this as an integer. If you write type, let's say if you write type num1, you see Python saved it as an integer. So I just want you to see that. So all right, so I just wanted to see that. Now let's move on. So here is what we say call a float. Once a number has a decimal point, it's called a float. An example of a float can be a equals to 15.4, or you just say 0.3. If you say 0.45, it means 0.45. If you print a, is going to show you 0.45. So if you just say point something, it's actually 0. Now you can use standard notations. You can write it, you can have this decimal points, for example b equals to negative 0.447. Oh, very possible. And we can also use standard notations. For example, if you want to write the string, let's say you want to write let me wipe all this stuff. Let's say you want to write a string. A moment. All right. Let's say you want to write 2. Sorry. If you want to write 2 times 10 raised to the power 7, or you want to write 2, or let's say you want to write let's say 3 in this case, or let's just say you want to write 5.3 times 10 raised to the power -2. How will you do this in Python? Very simple. For example, in the case of 2 times 10 raised to the power 7, you simply write 2e7. Sorry, 2e7, or 2e, you can use plus 7. It means 2 times 10 raised to the power 7, or you can write 2e7. It still means 2 times 10 raised to the power 7. Now, 2 times 10 raised to the power -7 will be 2e -7. Or you can write 2e, yes, it's 2e -7. Now, let's say, for example, let's find 2 to the raised to the power -3, or times 10 raised to the power -3. It should be 0.002. So 2e -3, 0.002. So I just want to show you can also use this standard notation to write. And we also had one here, 5.3 times 10 raised to the power -2. We can write it in the form 5e we had 5.5 e negative 2. So it's 0.0055. You understand? Because if you go two places back from 5.5, you go one place back, 0.5, one place back, you have 0.005. So that's 5.5 e to the times, that's 5.5 times 10 to the power negative 2. So you can use this kind of notation to write floating points. Now, take for example, you know 2.5. Let's show you this. If you know 2, most of you know how to write fractions. For example, 1.5 and 2.5. Let's look at them. You know 2, for example, if you have something like 2.5, 2.5, or 1.5, or even 3.5. You guys know to convert this, you need to say, for example, if you want to convert 2.5 to its improper fraction or to its fraction form, you say 2 times 2 plus 1 is going to be equals to 5 all over 2. And here 1.5, we know is normally 3 all over 2, but to calculate it by saying 2 times 1 plus 1, which is 3 all over 2. And 3.5 is 2 times 3, which is 6 plus 1, which is equal to 7. You know, I take 2 times 3 plus 1. Here I said 2 times 1 plus 1. Here I said 2 times 2 plus 1. So 2 times 3 is 6 plus 1, 7. So here is it in fraction. So 2.5 is 5 all over 2. 1.5 is 3 all over 2. And 3.5 is 1 all over 2. So let's say, for example, we have A equals to, let me see this, A equals to 5 all over 2. That's 2.5. 5 divided by 2. Print A. Print A. Now, floating point object has functions that allow us to find if. First, it allows us to find the ratio. Now, if we say A dot as, in fact, let's continue. Move to the next. B equals to 1.5 is what? 1.5 is 3 all over 2. B equals to 3 divided by 2. And let's say C equal to, C is 3.5, which is 7 all over 2. So let's say 7 all over 2. Now let's print B and C. Now you see it's 1.5, which is 3 all over 2, and 7.5 is 3.7 all over 2 is 3.5. Now let's look for, Python gives us a function for a float which will show us the ratio. For example, let's start with 5 all over 2 and see if we say, which is 2.5, if we say A dot as integer ratio, you see it writes 5 2, which means you have to understand it's 5 all over 2. So it's trying to tell us the integer ratio of this is 5 all over 2. Note that not all floats have integer ratio. For example, I don't think 0.345, if we have some number, maybe let's say x equals to 1.723, I don't think it must have an integer ratio. Let's see dot as integer ratio. All right, it has, you see, some long number. Normally you won't be able to calculate this most of the times. It's so long. So not all numbers have convenient integer ratio. I just want you to know, but you have special numbers like 5 all over 2, which gave us that's 2.5. For example, if you write 2.5, you see 2.5 gave us 5 all over 2. Now b is equals to 3 all over 2, which is 1.5. Now let's print b. Now let's find the integer ratio of b dot as integer ratio gives us 3 all over 2. Let's print c. Let's find c dot as integer ratio, c dot as integer ratio. It gives us 7 all over 2. So I just want you to know, if you really need this computation in Python, you can be able to convert from a ratio, that's a number with a decimal point, to its integer, that's from a decimal point number like 3 all over 5, you can be able to convert to its integer ratio. So for example, I can say message equals to, see what I'm going to say. I can say message equals to, this is a equivalent to in fact, what I can do first is to save the integer ratio on a number. For example, I can say ratio equals to c dot as integer ratio. Now I can compute a message. I just want to show you can actually use it. It's actually usable. You understand? So I can now say message equals to is a equivalent to something all over something. So you see now dot format. In this case, it's c is equivalent to ratio 0, comma ratio 1. Now print message. So you see 3.5 is equivalent to 7 over 2. So I just want to show you, you can actually write programs that make use of as integer ratio. Now let's move quickly. Let's go to the next part. Let's minimize this. Now you see I showed you you can use as integer ratio, and it also allows us, for example, to know if a number has a decimal point or not. Let me show you what I'm talking about. For example, you can be writing a function that calculates the average of 3. Let's say average equals to 3 plus 4 plus 5 all over 2. Print, let me just write average. You see 6.0. Now what of if we don't want to print, but look, for example, if we set average equals to maybe 7, let's see what 7 will give us in this case. Sorry, this is not average, it's a mistake. It's supposed to be all over 3. All over 3. Let's print average. Now you see 5.33, it has a decimal point. So we allow the decimal point normally. We don't want to cut out the decimal point. But somehow you may have a number without a decimal point. Let's see. For example, if we have average, if we have 6 here, let's see if it's going to give us let's see. Yeah, let's see something. So let's do this, and let's print out average. Print average. Now notice it printed 5.0, but in case we don't want to print the 0, if it's just 0.0, you don't want to print the fractional part, since you just want to print 5, what do? You can convert it to an int, but you may be writing a program where you don't know if it will have a fractional part like this, because maybe the input is coming from a file, a database, or from a user. You don't know whether it's going to have an integer part, a fractional part like this, or just have 0.0. So you, within your code, you can't convert it to an int, because in this case, you will lose this part and it will not be good because this is different from this. So Python allows you to check if a number, a floating point number, is actually an integer. So for example, if we have a equals to 5.3333 and b equals to 5.0, we can ask Python by calling the method, we can check the method is integer. It said false, which means a is not an integer. But if we say b is integer, look what is going to happen. It said true. So we can now, within our code, when we look at conditional statement, within our code, we can check if the result is an integer. It should print, for example, in our case, let's say we have this, let me just do it for you guys so you see. Let's say average equals to 6. We can say if average dot is integer, integer like this, we can say to print average, else print int. Okay. Oh, if average, sorry, print, we can't do this. Let's do it again. So if average dot is integer, instead, since it's an integer, just print int of average. Yes. Else, you can now print average since it's not an integer in this case. Print, we are going to learn conditional. I just want to show for those who already know. Print average. So you see, in this case, it just printed 5 because I converted it to an integer because it's actually an integer. Though in the case you saw in the case above, it printed 5.0. So you can use all that to do something good. Now let's move to the next. So the last part right here is, you can see we have what we call complex numbers. So complex numbers are very simple. You can see a complex number can just be a number where you write 2. For example, you can say a equals to 2 plus 3, 4, j. That's a complex number. B equals to, you can say, 0, you just say 2j or j. If you write, I don't know whether j works, but I think 1j works. That's, so we can now print a, print b. You see, just 1j, which is 0i. It means the real part is 0. So now we can say c equals to 3.4 e to the 10. It can be a float. That's I plus 4.0 e to the 5j. I just want 4.044 e to the 5j. I just want to show it can be that complex. Print c. You see, you have one. So that's a very good example. So now those are complex numbers. For example, if you type a, you see complex. Type B is also going to give us complex, and type C is going to give us complex. So with a complex object, you can either extract the real part and the imaginary part. For example, let's say we have A equals to 10, 20 plus 640j. Now, if you say A dot real, it's going to give us the real part. Let me see, real. And if we say A dot imaginary, it's going to is going to give us, imagine, we can also find the conjugate. The conjugate of a complex number just inverts the sign. So we can say a dot conjugate, and you see what happens. A now is 20 minus 4j, and in this case we can say, let's see, b dot conjugate gives us minus 1j, because we had 0 plus 1j. Now it's 0 minus 1j. Python is discarding the 0, so we just have minus 1j. So I want you to see that there we have complex numbers. So as you can see from the integer section, you can represent integers. Take note of this. Here are some examples of complex number. A complex number the real part can be a float or an integer. So for example, here we had a float for the real part. Here we had an integer for the real part, and the imaginary part can also be a float. You understand? And in this case, this is just a real number, so it's not real. For example, I don't think it's going to be complex. Let's say a equals to 10 plus 0j. I don't think that makes any sense. If you say print a, I think it's an integer. Let's print a. All right, it's still a. All right, it's still a. Let me try type a. All right, it's still complex. So you can have 10 plus 0j. Oh yeah, complex numbers can be 0 at the imaginary bit. Imaginary 0. All right. So to declare a variable in hexadecimal, we have seen this above. You use 0x. To declare it as octal, you use 0o. To declare it as binary, you use 0b. And you can do what. So here are some examples. A equals to 50, B equals to 00, it's still 50. C equals 032, which is still 50. And you see, and b equals to this, which is still 50. But we save them in different forms. Here we use this binary decimal, here we use octal, here we use hexadecimal, and here we use binary. And you can see from the result, it all printed 50 50 50. So internally, Python saved them as regular integers. So there is an example. Now you can also see for floating points, 5, for example, 5.2e to the 6 means 5 times 0.2. This e means times 10, and the power here is 6. You can also use 5.2e plus 6. Here we have 2.3e minus 30, which means 2.36 times 10 raised to the power minus 30. So just a simple example for you to understand. And finally, we can see a complex number consists of an ordered pair of real floating point numbers denoted by x plus y, j, where x and y are real numbers and j is an imaginary number. So at this point, we came to the end of the tutorials, but I may end, let me check. All right, so I would have ended with an example, a real serious example, but it's going to take a lot of time, and I want these videos to become a lot more shorter. So maybe sometime I'm going to show you an example of where you can use numbers to do the quadratic equation solver. But till then, I'll see you later. All right, so have a nice day.